Continuing in section 1.5. Midpoint, a point that divides a segment into two congruent segments. Well, what is congruence? These are figures that have the same measure and shape. Therefore, if I have a segment AB and I have a point M denoted as the midpoint, then I know that AM is congruent to MB. This is the symbol for congruency. And when segment AM is congruent to segment MB, then I know AM is equal to MB, which means the length of AM is equal to the length of MB. We could also show that in a diagram by symbols of congruency. So if I see a figure that has a tick mark on either side of a point, then I know that these two segments would be congruent, and that point would be the midpoint. Definition of a segment bisector: any line, ray, or other segment that intersects at the midpoint. Let's take a look at a couple of diagrams that represent segment bisectors. Here, line N is the segment bisector of segment XZ. Therefore, in the diagram, I know that line N must intersect or go through the midpoint of segment XZ. When I know that XY is congruent to segment YZ. I can represent that in the diagram with tick marks. So whether I represent it with an expression or in the diagram, I know that Y must be the midpoint, and since N passes through it, that is the segment bisector. I also know from congruency that the length of XY must equal the length of YZ. In the next diagram, I know that ray CE bisects segment BD. Therefore, I know that ray CE must pass through or intersect the midpoint of segment BD. When I know that segment BC is congruent to segment CD. I can represent that with tick marks in the diagram or with an expression: BC is congruent to segment CD. I also know, since they are congruent, in the next diagram, I know that ray CE bisects segment BD. Therefore, I know that ray CE must pass through or intersect the midpoint of segment BD. When I know that segment BC is congruent to segment CD. I can represent that with tick marks in the diagram or with an expression: BC is congruent to segment CD. I also know from the definition of congruency that the length of BC is equal to the length of CD. Let's look at an example. Use the diagram to answer the following question. Here, we're given that RT equals 4x minus 2 and RV equals 12x minus 24, and we want to find the measure of each segment. From the diagram, I know that T must be the midpoint of segment RT and TV because of the tick marks. Therefore, I do know that RT is congruent to TV. I'm given that RT equals 4x minus 2. From this expression, I know that if RT is 4x minus 2, TV is also 4x minus 2. And from previous slides, I know that I can use the segment addition postulate. If T lies between R and V, then I know that RT plus TV is equal to RV. Then all I need to do is substitute the expression values into this formula, and I can solve for the variables. Here, RT is 4x minus 2. TV is 4x minus 2. and RV is given to be 12x minus 24. Then we simplify and solve. I'm going to get 8x minus 4 equals 12x minus 24. Therefore, I know that 4x is equal to 20, and x is equal to 5. Now I just substitute into each expression, and I can find the value for each of my segment lengths. RT is equal to 4x minus 2. Therefore, when I substitute in for 5, I get 4 times 5 minus 2. 20 minus 2 is 18. Since I know that RT is congruent to TV, if RT's length is 18, TV's length is also 18, and therefore I know from the segment addition postulate that 18 plus 18 gives me RV to equal 36. In my next example, I'm given that K is the midpoint of segment JM. Find the measure of each segment if given Km is equal to 3x minus 1 and Mj is equal to 8x minus 14. Let's start by drawing a diagram. I'm given segment JM, and I know that K is the midpoint of JM. Therefore, that tells me that the length of JK is equal to the length of Km. I also know that tells me that segment JK is congruent with segment KM, and I can denote that in the diagram with tick marks. From the problem, Km is equal to 3x minus 1. Since these two segments are congruent, JK is 3x minus 1. From the segment addition postulate, I know that K lies between J and M. Therefore, JK plus KM is equal to JM. Now I just substitute the known expressions into the formula. 3x minus 1 plus 3x minus 1 equals 8x minus 14. Now I just simplify and solve. 6x minus 2 is equal to 8x minus 14. Therefore, 2x is equal to 12, and x is equal to 6. Now I just substitute that value into my expressions to solve for my segment lengths. JK is equal to 3x minus 1. Substituting 6 in for x, 3 times 6 minus 1 equals 18 minus 1, which is 17. Knowing that JK and KM are congruent, that means this segment is 17 and this segment is 17. From the segment addition postulate, I know that JM is equal to the sum of my two segments. Therefore, JM is 34. In my next problem, I'm going to go back to a number line problem. Here they want us to use the diagram to answer the following questions. We're given the number line, and I have x and its coordinate being a negative 3. I have y and its coordinate being 4. They want us to find the length of xy, and I know it's a length because I do not have a symbol for segment on top of my xy. So that means I need the formula, which is going to be a minus b. A represents the coordinate for value of x, which is a negative 3, minus b, which is the coordinate for y, which is going to be 4. Therefore, the length of segment xy is 7. Now what we want to do is determine the midpoint of segment xy. This is the formula to determine the coordinate of the midpoint of segment xy. It is the coordinate of A plus the coordinate of B divided by 2. Here, A represents the coordinate of x, which is a negative 3, plus B, which is the coordinate of y, which is 4. Then I just divide that by 2. Negative 3 plus 4 is 1 over 2. Therefore, the coordinate of the midpoint for segment XY is going to be 1/2. Now, I could signify in the diagram this segment being congruent to that segment with tick marks. And the last question, find the coordinate of the midpoint of XY. We already did that from the previous example, which is 1/2. In our last example, we are given a diagram with a lot of information. Let's analyze the diagram before we go down to our questions. Here, we're given segment AD and segment BC. The single tick marks tell me that segment BE is congruent to segment EC. Therefore, E is the midpoint of BC. And that tells me that segment AD passes through the midpoint, therefore it is a segment bisector. But segment AD has two segments between AE and ED. Therefore, segment AE is congruent to segment ED because of the double tick marks. And that also tells me that BC must pass through the midpoint of AD. Therefore, that is also a segment bisector. Therefore, these are bisectors of each other. With that information, we can go down and answer the questions that are being asked. We're first given that AE equals 7x minus 2. And AD is equal to 16x minus 6. Find the value of x and the measure of each segment. Well, we know that AE is congruent to ED. So if this is 7x minus 2, this is 7x minus 2. From the segment addition postulate, I know that if E lies between A and D, then AE plus ED equals AD. Now, I just substitute in the expressions. 7x minus 2 plus 7x minus 2, and that equals AD, which is given to be 16x minus 6. Simplifying and solving, I get 14x minus 4 is equal to 16x minus 6. That gives me 2x equal to 2, or x is equal to 1. Now I just need to substitute back into my problem and solve for each segment. Here, AE is equal to 7x minus 2. Substituting in 1 for x, I get 7 times 1 minus 2, which gives me 5. Therefore, AE is equal to 5. Then that tells me that ED is equal to 5. And from the segment addition postulate, I know that AE is 5, ED is 5. Therefore, AD is the sum of those values, which is 10. In the next question, we're given that EC is 12 feet. EC is 12 feet. Therefore, from the information I derived earlier, I know that BE must be 12 feet. And what they're asking me is, find the length of BE, which I already did, and find the length of BC. Here, it's just the sum of these two values by the segment addition postulate. So BC is equal to 12 plus 12, which is 24 feet.